Hi there, Slick Steve here with part 4 of my guide to Segwit. To see part 3 or to see my other videos, go to slicksteve.com. What is the Lightning Network? The Lightning Network is an off-chain micropayment system which is designed to make transactions work faster in the blockchain. It was conceptualized by Joseph Poon and Taj Dreijer in their white paper which aimed to solve the block size limit and the transaction delay issues. It operates on top of Bitcoin and is often referred to as Layer 2. As Jimmy Song notes in his Medium article, the Lightning Network works by creating a double-signed transaction. That is, we have a new check that requires both parties to sign for it to be valid. The check specifies how much is being sent from one party to another. As new micropayments are made from one party to the other, the amount on the check is changed and both parties sign the result. The network will enable Alice and Bob to transact with each other without them being held captive by a third party, aka the miner. In order to activate this, the transaction needs to be signed off by both Alice and Bob before it is broadcasted into the network. This double signing is critical in order for the transaction to go through. However, here is where we face another problem. Since the double check relies heavily upon the transaction identifier, if for some reason the identifier is changed, this will cause an error in the system and the Lightning Network will not activate. In case you are wondering what the transaction identifier is, it is the transaction name aka the hash of the input and output transactions. Now, you might be wondering, what would cause the transaction identifier to change? This brings us to an interesting bug in the Bitcoin system called transaction malleability. What is transaction malleability? Before we understand what transaction malleability is, it is important to recap one of the most important functions in the cryptoeconomics model, hashing. We have written an article before which covers hashing in detail. Just to give you a brief overview, a hashing function can take in any input of any length but the output it gives is always of a fixed length. However, there is another important function of hashing that you need to know to understand the transaction malleability bug, as it is called. Any small change in the input data will drastically change the output hash. One more thing that you need to understand about the blockchain is that it is immutable, meaning, once the data has been inserted in a block, it can never ever be changed. While this proves a safety net against corruption, there was one weakness that nobody saw coming. What if the data was tampered with before it even entered the block? Even if people found out about it later on, there was nothing that anyone can do about it because data once entered in a block can never be taken out. That in essence is why malleability of transactions is such a problem.